Imagine yourself racing a bike. This is a much harder and faster competition than you've ever been with before, and you've been training all year for this one race. You're 30 minutes into the race and you have 15 minutes left to go. Then all of a sudden you look down your arms and realize you're not sweating as much as you did in your warm up. Then your muscles completely cramp up and stop working. You look down and you can see them contracting even though you're not pedaling anymore. At this moment you ask yourself, am I dehydrated? Hydration is just as important in athletic performance as training is. Studies have shown that athletes who compete hydrated have a better chance of finishing in the top 10% of the racers than racers who are dehydrated. Water has a really important function in the body. There are three main things that it does. It is the main component of sweat, which cools down your core temperature. It balances the electrolytes on the inside and the outside of a cell, and also it functions and helps with muscle contraction. When you start working out, your sweat glands will open up and you'll start to secrete out sweat. Sweat is made of water and electrolytes. Electrolytes here are potassium, sodium, and calcium. When you're working out, your body gets really hot because there's a lot of metabolic systems that are working. So you put water on your skin to vaporize it or to have it evaporate. When it evaporates, the chemical bonds that are holding everything together, the water molecules like oxygen and hydrogen, they'll break and be evaporated out. This breaking and releasing of energy from the molecules is what cools down your core temperature so that your body can maintain the proper temperature that it likes to be at. Blood vessels will also surface to the top of your skin to speed up this reaction. So the faster that the molecules will break and release heat, the cooler your body can be. Along with water, electrolytes are also secreted out just to maintain normal body function. This is what leaves that residue on your skin when you're done working out, the very sticky feeling. This is the main way that you become dehydrated when you're working out. The reason why your body does this is, again, to reduce your core temperature. Your body will always pull out water from other parts of your body. So when you have secreted 2 to 3% of your total body water, this is the beginning of dehydration. And this is also the beginning of the decrease in athletic performance. Once you have continued and sustained exercise for long enough to secrete 15% of your total body water, this is complete dehydration, and this is when you will see paralysis, like in the story before. Your muscles will contract even though you're not working anymore. Water is so important to other functions of your body that sweating out too much can really affect your athletic performance. One of the main reasons is it takes water away from the cellular level. In your cells, water will balance the electrolytes from the inside and the outside of the cell. Electrolytes are really important because that's how your body will elicit a response for your muscles to contract. It's like the signals telling it, hey, I need you to start working, can you please contract? So the way that this works is that you have in a cell the membrane of a cell, which is circular and keeps the cell's components on the inside separate from the environment on the outside. What will end up happening is there is sodium and potassium. Both are charged atoms, which make them ions, because ions are any atom that has a charge. Both of them are positively charged. Sodium is found on the outside of the cell, and potassium is found on the inside of the cell. Sodium has a positive charge, and so does potassium, but to every 2 potassium ions, there are 3 sodium ions. So this creates a more positive charge on the outside of the cell than in relation to the inside. So the difference in charge is a very unstable environment for the cell to be in, but it is maintained this way through the cell membrane and the pores that are in the membrane. When your body wants to elicit a response or give a signal, it will open up the pores that are in the cell membrane and allow sodium to flush in. This equalizes the membrane potential. It equalizes the charge that is spread out between the cell membrane. That whole reaction of the sodium flushing into the cell and the equalization of the charge is what will send the signals to the muscles to contract. Water is so important here because it balances the concentration of ions from the inside and the outside of the cell. If you have less water, you'll have less sodium on the outside, then you'll have less sodium on the outside, than the amount of potassium you see on the inside, which greatly reduces the amount of response that you will get. It won't be as strong. Now, that also will affect your muscle contraction because those are the signals being signaled to your muscle contraction. But there's also more implication to being dehydrated to your muscle contraction. The way muscles are formed is there are filaments, which are long, stringy, fibrous-like components that are wound up. Underneath each wound up string is a myosin, which is a molecule that looks much like my hand when it's in this shape. There is a ball-like head and then a body or tail region to it, which is connected to another filament down below. What will happen in muscle contraction is the filaments that are wound up will unwind, which will release or show a spot to the myosin where it can bind. So if this is a filament, the myosin will bind to the filament and fling it forward. The filaments make up or are stacked on top of each other, which make up a sarcomere. And sarcomeres are stacked up above top of each other, and that's what makes a muscle. When a filament is flung forward by a myosin, it shrinks, which shrinks the entire sarcomere, which will shrink the entire muscle, which is, in relation, a muscle contraction. So once the myosin has flung it, that is what's contracting my muscles, much like this. It's getting longer and shorter, and that's how muscles contract. Water will fill itself around each filament so that when it is starting to contract, then it will do it in a very smooth manner so it has lubrication. Also, water will surround itself around the myosin, and the myosin does not like to be in water. It is not a happy environment for it. So to get out of the environment of the water, it will contract as strong and as fast as it can so that it can go back down into its environment where it was before, where there is no water. So here, if you didn't have water, your muscles would not be able to slide with ease, and the myosin would move much slower because it's in an environment that it's okay to be in. So water is very important to have in your muscles when you're trying to continuously do exercise. Water is very important for athletes to have because it cools down your core temperature through sweat. It balances the electrolytes that are inside and outside of your cell, and it will lubricate your filaments while muscle is contracting, and it will create a very strong muscle contraction, which is really what we're looking for when we're trying to race or do any type of athletic performance. So in conclusion, racers who race hydrated are way more likely to finish in the top 10% of competitors than those who are racing dehydrated.